What can people expect in transportation in the 21st century? The age of steam launched ships which sailed the 7 seas, and railways which spanned the continents. But the glory of the steam age was surpassed in the 20th century by the automobile, and the airplane. The door-to-door efficiency of the automobile and its sheer convenience led to its rapid proliferation, to the point today where there are too many vehicles for the available roads. The result, worldwide, is chronic congestion, bringing with it serious social problems. Among the most severe of these problems is the damage caused by harmful exhaust gases. These emissions affect our breathing, poison plant life, and harm the environment of the planet Earth in a variety of ways. There is also the problem of traffic accidents, which every year cause untold damage to life and limb. Will we have to live with these social problems of pollution and noise in the next century? Surely, what is needed now is a new transport technology to solve these existing problems. HSST, standing for High-Speed Surface Transport, is a magnetically levitated, linear motor-powered transport system. HSST is a pioneer transport technology that overcomes the problems caused by friction between wheels and rails and noise pollution, but provides the same carrying power of conventional railways. Conventional rail transport has significant demerits. Because it is a system based on wheels and rails, it produces noise and requires costly maintenance. Magnetic levitation systems include those using magnetic forces of either repulsion or attraction. The repulsion system is an application of the repulsion force from the like poles of the magnet. HSST is the system based on attractive magnetism and is an application of the attraction force between iron and magnets. Electromagnets are installed in the lower part of the vehicle body where it wraps round a rail. When electrical current passes through the magnet is attracted to the rail. Left alone, the vehicle body would stick to the rail, so a special sensor is installed to control and maintain a constant distance between the rail and the vehicle. The electrical magnet and the rail form a closed circuit for the magnetic force to pass through a fixed route, preventing the dispersion of the magnetic field. And as the vehicle and the rail are attracted to each other, should the vehicle stray off course, it can be smoothly restored to the right position. So much for how the vehicle body is raised. Now, how does it move forward? HSST vehicles are propelled by linear induction motors, which are, very simply, like ordinary rotary electric motors, but separated and laid out flat. An ordinary rotary motor has a coil or coils and rotors. A linear motor is created by placing the rotors on a flat surface and placing the coils on the vehicle body facing the flat surface. When electrical current is induced through the coil, the resulting force occurring between the rotor and the coil drives the vehicle forward. In the HSST, modules have been designed to provide a combination of electromagnets for levitation and linear motors for propulsion. As the modules have no wheels or moving parts, vehicle maintenance is very simple. HSST makes use of practical and perfected technologies such as magnetic levitation and linear motor propulsion. HSST is a totally pollution-free transport system. Noise and vibration are virtually non-existent, since there is no contact between vehicle and rails, and that means too there is no frictional contact causing rubber or metal dust. At speed, all that can be heard is the sound of the wind. Has a silent and non-polluting rail transport system been developed by now? HSST, with its light vehicle weight and evenly spread load distribution, differs from the concentrated loading of conventional rail systems and needs a light, slim guideway structure. Because only a small area is needed for the HSST guideway structure, construction costs are low as a consequence. Additionally, the lack of frictional contact between the vehicle and the guideway means less wear and tear and less maintenance. Operating costs are reduced too, because the linear motors, having no moving parts, also require little maintenance. A safety feature of the HSST is its wrap-round body, which embraces the guideway, effectively preventing derailment or overturning. Linear motors have superior traction power on gradients and excellent acceleration capacity, permitting a wide range of speeds. Thanks to being elevated above the guideway rails, linear motors are not affected by rain or snow on the track, and acceleration and braking are not affected by weather conditions. A point to be stressed here is the smooth, comfortable and quiet ride. The HSST gets the highest marks for passenger comfort. HSST development started in 1970, when it was realized that new clean technologies were needed. Experimental vehicle HSST-01 was completed in 1975. In 1978, at a test track by Tokyo Bay, it exceeded its target speed of 300 kilometers per hour. In 1985, a more advanced vehicle, HSST-03, was demonstrated to the public for the first time at the Tsukuba Science Expo, successfully carrying more than 610,000 passengers. Next year, it continued its successful demonstrations at Canada's Vancouver Transport Expo 86. In 1989, a new vehicle, HSST-05, operated at the Yokohama Exotic Showcase, the first magnetic levitation vehicle in Japan to be granted a railway license by the Ministry of Transport. HSST-05, with its 150-seat two-car cabin, carried 1,260,000 passengers. Altogether, HSST vehicles have carried more than 3 million passengers, providing them with a unique transport experience in the form of HSST's silent, smooth and exceptionally comfortable ride. In 1991, trials of the HSST 100 vehicle for inter-urban transport use were started at a test site in Nagoya. The results of a 4-year investigation and tests indicate that HSST 100 has reached a stage where it can sufficiently service the public as an inter-urban public transportation system. Also, the Japanese Ministry of Transport agrees that there is no technical problem for the commercialization of the system. HSST has been developed for intercity and airport link use, but it is also an excellent means of transport for inter-urban and residential areas. HSST's slim guideway structure and quiet operation help to preserve the environment in the cities of today. HSST, with its high capacity, can handle a high volume of commuter traffic during peak hours. The Park and Ride residential HSST line promises passengers a comfortable commute. On holidays, inner city dwellers can ride the HSST to visit the suburbs. From city centres, HSST is an unrivaled system for airport access.